Qualitative truss analysis means applying equilibrium to determine whether a member is in tension or compression without actually performing calculations. There are two methods typically used for truss analysis: the method of joints and the method of sections. Qualitative truss analysis can be used with either. Both methods start by applying rigid body equilibrium to the entire truss in order to find the reactions. By summing moments about the right support, we see that the applied load causes a counterclockwise rotation, so the left reaction has to be up to balance it out with a clockwise rotation. Since the moment arm from A to E is larger than from B to E, the vertical reaction at A is smaller than the downward force. Therefore, when we apply vertical equilibrium, we have a smaller upward contribution from A, a larger downward force from B, and an unknown reaction at E assumed up. The result is a positive reaction at E, so it is up. Horizontal equilibrium tells us that the horizontal reaction at E is zero. If we want to use method of joints, we can start with joint A. I always draw the unknown axial force as pulling. If the result of equilibrium is positive, the member is in tension. If the result of equilibrium is negative, the member is in compression. Let's apply vertical equilibrium. We have a positive contribution from the reaction and a positive contribution from the vertical component of member AF. Solving for the vertical component of AF, we see that the result is negative. If a component of the force is negative, all of the member force is negative, so AF is in compression. Next, we apply horizontal equilibrium. We have a positive contribution from AF, but the quantity is negative, and we have a positive contribution from AB. When we solve for AB, we see that the result is now positive, so AB is in tension. If we wanted to find whether member FG is in tension or compression, we could use method of sections. To find member FG, we cut the truss through these members. Let's try using the left section. Again, I always draw the unknown axial forces as pulling. By summing moments about point C, we get a positive contribution from the reaction, a negative contribution from the applied load, and a positive contribution from member FG. We know that the reaction is smaller than the applied load, but the moment arm for the reaction is larger than for the applied load. So we can't tell from this free body diagram whether member FG is going to be in tension or compression. So let's try the other section. There is no applied load on this section. The reaction at the right is up. There is no horizontal reaction, and we have the same three unknown axial forces. We sum moments about the same point, point C, because it takes care of two of our unknowns. This time, let's take counterclockwise as positive. We have a positive contribution from member FG and a positive contribution from the reaction at E. When we solve for member FG, we see that the result is negative. So FG is in compression. Sometimes there is no way to know whether the answer is positive or negative without knowing the magnitudes of distances and loads. In those cases, for those members, our qualitative analysis is inconclusive. However, for most truss members in most situations, we can determine tension or compression with confidence.